So in an octagon, we have 8 sides. If you divide 8 into 360, what do you get? 360 divided by 8.
45 degrees.
45. So what triangle are we going to use for an octagon?
45.
So in this exercise, since we're going to use our triangle, we need to use our straight edge to make sure that our center lines are perfectly horizontal and perfectly vertical. So in the upper part of your paper, just like we did yesterday, let's go ahead and we're just making a line. We're going to use it as an intersection for our center mark. So this line will actually become our center mark. And we're going to have to use our straight edge since we're using our triangle because we have to be flush with the straight edge. So I used my horizontal edge to make that line. And then I'm just eyeballing it. We could bisect it, but we don't have to here. We're just using it as a center mark. So I'm coming up here and I'm making a vertical line just to have a center mark. And we talked a little bit yesterday about our objects having the circle on the outside and the circle on the inside, and that circle is called a construction circle. So if we make the polygon on the inside of the circle, what's that called? If the polygon is made on the inside of the circle, what's that called? Inscribed. And if it's inscribed, the distance across the points is equal to the diameter, correct? If it's circumscribed, then the construction circle is made and the polygon is made on the outside of the circle. And then the distance across the flats is what's equal to the diameter. Okay? So if we have an example that gives us the dimension across the flats, we need to make it circumscribed. If we have an example that gives us the dimension across the points, then we need to make it inscribed. So for this one, we're going to make it circumscribed, and we're not going to set it to an actual number because remember this is just practice. So I want you just to wheel your compass out to where it's going to stay within your center mark. So we know if our center mark goes out that far and I just wheel my compass out about that much, then I know my circle is going to stay within my center lines. Okay, that way we don't have to expand our center line. And we're not really measuring anything at this point. If we were doing an actual drawing, we would have to put whatever radius that was required. But for us, we're practicing. So we made our center marks with our straight edge. We made a circle at just some given radius that we came up with ourselves because we didn't measure anything. So after you get your circle made, you're going to put your 45-degree triangle along your straight edge. What happens with this is we'll line it up tangent to the circle. Okay? So I'm tangent to the circle here. I'm going to go ahead and make a line. Make sure it's your 45-degree triangle. So I've made a line. I don't have an estimate on how far that line should go out, what'll happen is I'll make lines, and if they overlap, I'll just erase what I don't need. Then I'm going to move my 90 side, this is the straight vertical side, up tangent to that quadrant there. And I'm going to make another line. All right, so line your straight edge up with the other side in the quadrant. And we just keep flipping our triangle around until we get all the lines that are tangent. And then the last two lines are going to be horizontal lines that we need to make with our horizontal straight edge. So you're going to have horizontal lines at the top and bottom quadrant and vertical lines at the right and left quadrant. And then when you erase out, if you want to erase out with your eraser shield, so you don't have to redo your corners, you could do that. And you come out with a nice, neat octagon. So since with our hexagon we divided 6 into 360, and with our octagon we divided 8 into 360, if we had to do like a dodecagon and figure out the angles, what would we figure out there? How would we do that? That's 12. So what would we divide into 360 to figure out our angle? The 12, right? So we have a nice octagon shape after we're done. And this octagon was made with your 45-degree triangle, and it's made circumscribed. All right, we're going to make one more polygon, and then I'm going to show you how to do the problem from our worksheet example. So the polygon we're going to make is a pentagon. All right, and pentagon has several steps. We're going to have to create it in scribe, so it's going to be inside the circle. But there's going to be a number of geometric constructions that we have to do before we actually make our pentagon. So the first thing that I want you to do is just draw a line. And give yourself a little bit of room on this one so you can make it a little bit bigger. What happens with the pentagon, there's so many geometric constructions that if you make it tiny, you'll never be able to draw the pentagon at the end. So maybe make a line about 3 inches. Give yourself a little more room. And then again, we're using this as a center line, so we're just going to eyeball this one and make another vertical line straight up and down. And if you feel like you're going to need a little more so you can make a good circle, you know, you've got plenty of room on your paper to do that. So now that our center mark's a little bit longer, when we put our compass out to make our circle, you know, give yourself plenty of room. So my circle is going to be about a 2-inch circle, it looks like. So once you have your center marks and you wheeled your compass out to where the circle is going to stay within your center mark, just strike your circle. We didn't measure anything. We just made sure that when we wheeled our compass out, it was going to stay within our center marks. Mine's about 2 inches because I drew my center lines a little over. So once you have your circle made, the first step is to bisect the distance between the center point and this quadrant here. So between the center point and the quadrant, we're going to bisect that line. So we're going to try to find the exact center between the center point of our circle and the quadrant of our circle. So don't do your whole center or your whole center mark here. Just do between where the quadrant is and the center point. So you're going to take your compass, and remember when bisecting a circle, we just wheeled it out a little bit past the half mark. So something like this. And when you put your compass back in, try to get back in that same hole that you made so you're not off center too bad. So once you wheel your compass a little bit halfway, you'll put it in that same center mark hole that you used, and we'll strike an arc. So here's my arc on that side. And then I'm going to put my needle point in the quadrant point, not at the end of my center line, at the quadrant point. So where the circle touches your center mark. So I put my needle point there, and I'm striking another arc. And if you remember from yesterday, once you strike that arc, you have 2 points. And when you have 2 points, you can make a line. So I'm taking my straight edge and I'm putting it in between those 2 points. And I'm making a line. There's a little bit off on that one. So what we needed to find here is this point. We needed to know that midpoint. Could we have measured that? Yes. But this shows you that we can find things without measuring, and you know the geometry works out. So we have that center point, and now what you're going to do is take your compass and you're going to put the needle at that point that we just found, okay? And you're going to wheel out your lead to the top quadrant. So we need to know the distance from this point to that top quadrant. All right? So my needle point is here at this intersecting point that we made when we bisected the line, and I'm wheeling it out to the top quadrant. Once you have that exact mark, you're going to strike an arc. And you want to strike it all the way down here to make it cross our center mark on that side. And what we were actually finding there is this point. Okay? So the first thing that we needed to find was this midpoint. Then the distance from the midpoint to the top quadrant is this distance over. But what we're actually needing to find, and this is going to be the sides of our pentagon, the distance between this point and this top quadrant is our actual size of our pentagon lines. Okay? So several steps here to create this pentagon. So that our next step, once we know this point, is to take our compass and we're going to put the needle point at the point that we know, and it's only going to be slightly larger. If you'll notice, it's just a slightly larger amount than the other arc that we just made. But you want to put the lead side up here at the top quadrant and the point at that point that we just found. Okay? Once you do that, that's the side, or that's the length of the sides of our pentagon. And just so you can check yourself, you can strike a little arc up here, make sure it does intersect. Because if you get off just a little bit, then your pentagon won't match up at the end. And if you are off just a little bit, adjust your compass to where it's exactly on that quadrant. So mine looks pretty good. Once I get that radius from that arc that I just made, I do not want to change anything on my compass. I want to keep it the same because, again, that's the sides of our pentagon. So I'll put my needle point at that intersection, and I'm just going to go around the circle just like we did when we created that hexagon. And at every arc I strike, that becomes the next point where I put my needle point. And you should end up getting, if you test yourself at the end, you should be able to put your needle point in that last mark and it end up back on your top quadrant if you did it correctly. And remember, just a little bit off in one of these steps can cause your pentagon to be off. But once you have those 5 points, or really 6 points because you have 5 segments, then all you have to do is take your straight edge and connect those dots. Then we have a regular polygon pentagon. And what did we say regular polygon meant? It had all equal sides and all equal angles. So we made a pentagon with our compass, and it was inscribed. And just a little note that it is a regular polygon. And there are lots of other things that we could learn, like making an arc tangent to another arc, making a line tangent to an arc, that kind of thing. And that's where it's going to lead us into our next step, because we're going to do some drawings where we have to understand how to create some of this geometry. So if we look at our textbook here, we're going to do this example first, because if we can do this example, we can easily do the other example. And even in AutoCAD sometimes, I know we have the fillet command, but fillet doesn't always work how we want it to work. So there may be a time where you have to actually create circles like you would with a compass to get some of this geometry. Especially the older versions of AutoCAD, they are more advanced now with the fillet functions to create curves, but sometimes it doesn't do exactly what we want it to do. So it's good to know how to create this stuff. So if we look, we have this overarching curve is what we're trying to make tangent to these two circles. And here's the example. If we have a boss here where maybe we put a fastener of some kind and a shaft of some kind in the other end, and those two things are supposed to work together, but we have this rib that connects them. And then we have this underlying bottom part of the rib. So we have to try to figure out how to make that arc tangent to two other arcs. And we have to find what the center point would be for that arc. So I know a lot of times when you're looking at mathematic problems, especially word problems, it sometimes, you might get a little bit nervous working with letters instead of numbers. But these are basically numbers that we're going to input to solve this equation. Hurry back. Okay, so if we have HK is essentially the radius of this overarching arc. So HK is the very large radius that we're trying to find, or that we're trying to, on the arc that we're trying to make tangent to the other two arcs. And then the small circle, we're going to say has a radius of little r, and the larger circle has a radius of big R. So we know the center points of this circle and this circle. We're trying to find the center point of HK so we can make that arc. All right? Now, you don't have to do this on your paper. I'm going to do it on mine so I can have some space where you can see the math problem. So again, we're going to pretend like we have a small circle and a big circle. And so in order to do that, I'm just going to create a couple centimarks here. If you want to try this, you can. And I staggered them, kind of like the example. I haven't measured anything yet. I will have to measure in order to find the right radius on this. But for now, I'm just going to make my circles to fit my center marks. I'm going to make this one a little bit bigger just to be like the example. So I have two given circles. I need an arc that's going to be tangent. And my tangent points, I know about where my tangent point's going to be. It's going to be right in here and right in here. But I can't just guess. I have to actually do geometric construction to find the real tangent point. So let me zoom out a little bit so you can see this. So I know I need an arc that goes with these two tangent points. I am going to do a little bit of measuring because I need to know what these radii are now. Normally we'd be given this. So that's right at a 1/2 inch. So we're going to say little r is equal to 0.5. And then big R I'll say big R is 0.75. Okay? And because this is trial and error, I didn't actually put dimensions on this thing. I'm going to just make sure that I'm choosing a radius that's going to work. Okay. All right, we're going to say that this arc needs to be 2.5. So HK is going to be 2.5. Okay? So here's my numbers. We already know this one because little r, remember little r was right here, so we're going to say that this is 0.5. So the distance from the center outside the circle is 0.5. Everybody good with that? Because we know what the definition of radius is. And we're going to say the center here to the outside of the circle is 0.75, correct? Because that's the definition of radius. And then we don't know where the center point is for HK. We're thinking it's somewhere around in here, but we've got to find that center point. But HK for this arc that we're going to make has a radius of 2.5. So whatever this is, wherever this comes to be, it's going to be 2.5. So things that we know the center point here, we know the center point here. So when we create this, we need to find out what the distance is between here and here, right? Because if we find that distance, we can find where the center point is. So how are we going to find that? What do you guys think? How will this work? We know it's going to be tangent, right? So let's say that this is our tangent point. Then we know that from that tangent point, it's going to be 1 inch across the circle. And then what's the rest going to be down to here? Do you know that yet? It's 2.5, right? Because our radius of that arc that's tangent is 2.5. So if we know the distance from this center point to here is 0.5, and then we need to know that distance, what's 2.5 minus 0.5? That's 2, right? So we can change out this question mark and put a 2 right here. So in our math, in our equation from our book, it says HK minus little r, which is going to be 2. Okay? And then HK minus big R, what's 2.5 minus 0.75? It's 1.75, right? So our distance here is 1.75. So why we needed to figure up this distance is because we can put our compass at this center, wheel it out to 1.75, strike an arc, then put our compass to this center, wheel it out 2, and strike an arc. And then that's going to give us, where those two arcs intersect, that's going to give us the center point for that tangent arc. Okay, so let's try that. I'm going to, and your distances might be different, okay? Because if you're doing this with me, you're going to have to measure what your circles were. But just follow along with me. First thing I'm going to do is set my compass to that 1.75 and make that first arc. So I'm coming up here, I'm striking an arc. So here's my 1.75 arc. I was a little off on my guessing, right? That's why we have to actually do this. And then I'm going to set my compass to 2. So I've got it set to 2 inches. I'm going to put my needle point here, and I'm going to strike an arc. And where they intersect is now my center point. Okay, we thought it might be a little bit further down, but it's actually here. So now I can set my compass to 2.5 because that's the actual size of the arc that I need. Because now I can make HK, since I know where the center is, I'm going to use that intersection . So my tangent points are actually a little bit different from my estimate. And I'm a little bit off from here. I don't think I had it set exactly at 2.5. But I estimated my tangent point to be here. This one was a pretty decent estimate because I was close. I think if I wheeled my compass out a little bit more for 2.5, I'd actually hit that. And I'm a little bit short here if you can see that. So that's why I know I needed to wheel it out a little bit more. But my tangent point here was actually further down. Here I estimated pretty close. So I found the tangent point to the 2 arcs with that given radius by using the known center point. So we're actually going to do that in a drawing. I know that looked very complex, but once you do it in a drawing, you'll understand it a little bit more. So this drawing is posted online for you to find. But it's called the rocker arm. And we're going to draw this as a board drawing first, then we'll draw it in AutoCAD. So we have several things going on here. We have an arc that's tangent to these 2 upper arcs. We have an arc that's tangent on the bottom. And then we have a hexagon that is actually rotated 15 degrees. And we know the distance across the flat, so we're going to make it inscribed or circumscribed. We're going to make it outside the circle because we know the distance across the flats. All right? So a lot of geometric construction going on in this one drawing. So for now, what I'm going to let you do, we're actually going to draw this. I'm going to give you a few minutes to get your paper and get everything set up, and we'll draw it together.